At the 2021 Objectivist Conference, ARI CEO Tal Tsfany announced the Ayn Rand University, a major expansion of ARI's educational offering. During this year's conference, he gave an update on the growth of ARU. As part of the presentation, he announced a large expansion of our course offerings for the 2022-2023 academic year. Today we're going to discuss the new ARU course catalog, and in particular, talk about one of the new courses being offered on the foundations of physical science. Welcome to New Ideal Live, the podcast of the Ayn Rand Institute. I'm Mike Mazza. With me is Keith Lockitch, who will be teaching the physical sciences course. So, Keith, I want to start by asking you about the ARU vision before we talk about your physical science course. So you're the VP of Education for anyone in the audience who doesn't know. So you've been involved in the planning and strategizing of ARU. What's the vision? The old program, the Objectivist Academic Center that I graduated from, was promoted as training for professional intellectuals, intellectual professionals. Is that still the target student, or do we have something new in mind?
No, so we do have something new in mind. So the vision partly has to do with our perspective on, you know, who is the potential audience that can benefit from the kinds of products that we can offer. And you alluded to the OAC, or the Objectivist Academic Center. We're retiring that term, and we're really trying to stick to the new, we have a vision for a broader offering, and we're calling it Ayn Rand University to reflect that broader vision. So we're trying not to say OAC, and we're trying not to say ARI. We're trying to say ARU. I mean, not that the institute is going away, but when we talk about this program, we're talking about Ayn Rand University. So as you said, in the past, our primary focus has been on finding and training people that we think of as future professional intellectuals or intellectual professionals, people who in some way are going to draw on their knowledge of philosophy, of objectivism in their professional work, whether as a professional intellectual or in some other capacity. So in our recruitment and our admissions in the past, we put a lot of emphasis on a person's potential for some form of intellectual career. Those are the kinds of people we were looking for. And our curriculum was very narrowly focused on developing the kinds of knowledge and the kinds of skills that are necessary for somebody who works in an intellectual capacity. So, from our point of view, that consists of a deep knowledge of objectivism. I mean, a broader knowledge of philosophy in general and how objectivism is situated within the history of philosophy, and then training in thinking and communication skills. So these are the sort of basic skills that a professional intellectual needs. But in thinking about ARI's strategy over the last couple of years, we think there's a much broader audience who can benefit from the kinds of education that we as ARI can offer. So what if we could attract any young person who's ignited by Ayn Rand's writings and ideas, excited by the vision of the world that Ayn Rand has to offer, and wants to use them to forge their own path in life, to create a life worth living for themselves, whether they're interested in an intellectual career or not. So this will still include potential professional intellectuals and intellectual professionals. That's still a special focus for us and a special target audience. But what we think we can offer is much broader than what we've been offering in the past. And the way Tal Tsfany likes to put it, our CEO, is that what we want to offer is a foundation for life that's grounded in objectivism.
Okay, so then how did the new course offerings align with that vision? As you mentioned, in the past, it's been pretty much philosophy, communication. This year, we're offering classes in a variety of subjects. So how does that all fit together into the new vision?
Yeah, so the idea in offering a foundation for life, um, the idea is that we're expanding the range of subjects that we cover on the grounds that what it looks like to be an educated adult and to have the foundation that's required to succeed in the modern world and forge a life worth living for yourself is that there's certain subjects that are sort of the pillars of human knowledge that I think any educated adult uh, needs not just to know something about them, but to know something about them from the right perspective and from the right framework. Our education system today, does an absolutely horrible job of preparing young people for life. So even if they might take courses in all different kinds of subjects, they don't learn them in a way that makes it clear, how this fits into, how this fits into life as a whole. So one of the things that we're doing is we're offering a range of subjects that we've never offered before. So if we could put up this is a screenshot of our course catalog. So as you can see here, and I guess we don't have the URL on this page, but you can see all these courses by going to university.aynrand.org. There it is. But if we go to the full screen, so you can see that we still have our core courses on philosophy and communication skills, right? There's a course called Philosophical Skills. There's an objectivism seminar. That's a continuation of a course that started last year. You can see my writing courses up here. So a lot of the core offerings that we've always been offering will continue because that's essential to what we do. But there will be some changes. I think one exciting addition is we're going to have Yaron Brook do some courses on public speaking. So you can see here a course on oral communication by Yaron Brook. So he's the former CEO, executive director of ARI. He's the chairman of our board, and if you know anything about him, you know that he's an amazing speaker and travels all around the world giving talks on objectivism. So we have him teaching a course on public speaking, but we also have new subject areas that we're adding. So if you look here, you can see there's some courses on literature. We're going to be doing a course on that's based on a lecture series that Leonard Peikoff gave called 8 Great Plays. So this is a course where he analyzes in detail 8 sort of world historic plays from the Western literary canon, and he presents a method of how to think about them and how to analyze them as literature. And so what we're going to be doing is we'll be having the students read the plays, listen to Dr. Peikoff's lectures, and then do assignments and have discussion sections based on this. So we're going to be drawing on this brilliant, fascinating discussion of literature by Dr. Peikoff. And then we also have some courses on particular great works of literature. Victor Hugo's 93, Dostoevsky's Crime and Punishment, and we have experts on literature in our community that we're drawing on to teach these courses for us. So we're drawing on a broader range of faculty. We're going beyond ARI staff. We're drawing on experts in the objectivist community that we can use, draw on their expertise to teach these courses. And part of what we're doing is expanding the subjects. You can also see here my physical science course is one of the things that's being offered. And we're going to talk about, that's what we're going to talk about today. If we go to the next image, the next courses image, you can see here. So again, more of our standard courses on communication and different aspects of philosophy. We also have this course here on the law. So Adam Mossoff, who's a professor of law at George Mason University, he will be teaching a course on on a legal system as an intellectual achievement. So and this is just the start. Obviously, there are other subject areas that we would consider the pillars of human knowledge, but this is the start of expanding into these different subjects. And just to be clear on what this means, what this doesn't mean that what we're going to be offering is sort of a complete college level education in these subjects. We have so Adam Mossoff will be teaching a course on the law, but he's not teaching law. Like, he teaches law at his university. We're not trying to replace that. and I'm teaching a course on the foundations of physical science. This is not an attempt to replace what you would get in a physics curriculum if you studied physics at a 4-year university. The idea is we're trying to introduce these subjects and talk about the foundations of these subjects from a unique perspective that's informed by objectivism's radical framework. And I think somebody who takes our courses and then goes on to study those subjects in a more traditional college would have a deeper understanding of what they're studying, why they're studying it, where it all comes from, and how it fits into human knowledge as a whole. So that's an overview of the vision and some of the ways in which we're expanding our course offerings.
Good. That's really exciting. I'm looking forward to auditing and teaching. uh, we have a few questions I think we should answer from the chat. One person asks if we're targeting a specific age group.
I
Do
mean, I
we?
think, yeah. Um, so so in one respect, no, because our courses, I think, will be available for auditing to people of all ages. There's going to be a lot of material that'll be really interesting, but, especially for people in our objectivist community who they've taken a lot of our courses, they come to our summer conference and so on. There's going to be, but what we're offering here will be new things that will be, I think, really interesting to people for auditing. As far as graded students, we are, I think we've traditionally attracted mostly sort of college age students, maybe some who are a little older, but I think we're trying to move in a direction where we're attracting people at a younger age. So somebody who's maybe coming out of high school, one idea that we have for this is the program that we offer could potentially be a really valuable full-time program for somebody who's doing a gap year or maybe taking 2 years between high school and college. They take our courses, do it as a full-time endeavor. And what it gives them is a really solid foundation, as we talked about, a foundation for life, a perspective on all these different subjects areas. If they take that then into their university when they go to school, um, you know, they will be much better prepared to understand, to put into context why they're even learning all of these subjects. So we're, I think, um, if we can attract students in the 18 to 21 age, that would be great. We don't necessarily
Mhm.
expect that to happen immediately. The part of what we're doing here is on the premise of if we build it, they will come. So we're expanding
Uh-huh.
our offerings. We're bringing in, these superstar faculty from our community, and we'll see. We want to offer these courses for the first time and see who we can attract, and try to get the word out there.
And there's a question if there's a PDF available. So all the information we have publicly available, you can find at university.aynrand.org. You'll find how to apply, what the different course offerings are with some descriptive information, pricing info. So that's where to look for that kind of information. So one last question before we move on to your physical science course. One last question about the university as a whole. So, how are these course offerings going to be structured? Are they going to be on an annual rotation every other year? Say I want to audit a class this year, but I don't have the time. Does that mean I've missed my chance? It'll never be there again, or what?
Yeah, no, I think so. I think some of these courses will definitely be offered again. As I said, in some ways, this is kind of an experiment. We're doing this for the first time. So partly we're going to run these courses, see how they go before we make decisions about whether any particular course will be run again. One possibility is that we might run a given course, you know, once or maybe even twice, and we record all these courses for internal purposes. But so once we have a really good recorded version of it, what we might do is offer it via the recording, and then the instructor or teaching assistant might lead discussion sessions and interact with the students in that way. But but the course could be offered again, maybe even in an asynchronous way. It'll just be available like the courses that we have on our campus.aynrand.org site right now. Those are just video courses that are available for people to take. Though I don't think we would do that, but we could potentially offer recorded versions in the future so that we can keep expanding the catalog,
Mhm.
quite significantly.
And just to point out that the critical race theory course that we offered uh, last 2 quarters, is coming back again next year. So that's an example of a experiment that went well, and we're going to repeat. It was a very popular, well-received course. And if you're
And I'm
interested in,
glad of that
yeah,
because I'm glad of that because I missed it the first time through. So maybe I'll get a chance to watch it this
well,
time.
I was there the first half, and then I had to teach my own course, and I kind of dropped away. So I have to listen to take the second half of the second version. But if
Yeah.
you're interested in that class, learning about it a little more, there was a podcast a few weeks ago, fairly recently, on with the instructors Nikos and Onkar. Um, okay, I think that's what we wanted to say about the ARU as a whole. Was there any final thoughts that you had about the new catalog, Keith?
No, I just think I'm really excited about the new offerings. Actually, one thing we didn't mention was you can actually see the video of Tal's talk at OCON if you
Oh,
go
that's great.
to the Ayn Rand Institute YouTube channel. Maybe we can. I don't think we plan to have this in the course notes, but maybe we can get the URL for that presentation. Tal's a good. Uh, he's a good speaker and he's very motivated. Like everyone who was at the conference was super excited about the new course offerings, including me, and I already knew what they were going to be. So take a look at that, and I hope you'll be end up being as excited about the what we're doing as we all are.
Good. Okay, so Keith, let's talk about your class. I'm excited to learn more about it. So it's the Foundations of Physical Sciences. Do you want to start by giving us just a summary of its content and some of the logistics, and then we'll get deeper into it.
Yeah, so it's foundations of physical science, but it's a very delimited aspect of the foundations of physical science. It's basically looking at, how do we know, how did we get to our understanding of the laws of motion and gravitation that Isaac Newton came up with. So um, it's not all of physical science. It's that very delimited aspect of it. And basically what we're going to be covering is the historical progression that starts with the basic observations that ancient man made about the objects that you see in the sky, the sun, the moon, stars, the planets. Starting with those basic observations and what was known to the ancient Babylonians, for instance. How do you go from that to through the whole historical progression that gets you to Newton's understanding of these things? So that's basically what the course is going to be covering. um, yeah.
Okay, so how many classes? How much? When does it start? How long will it
Yeah,
go?
so I'm going to be teaching this. So Ayn Rand University is on a quarter system, and the quarters it's roughly the typical academic year. We start in October, so we go Q1 is October through December, Q2 is January through March, etc. So this is going to be taught in the first 2 quarters. So it'll go basically starting in October, and it'll go through October 22 through March of 23. I'm going to be doing 10 sessions, 10 classes each quarter, so 20 classes, probably about maybe 2.5 hours each class. I do plan also to do office hours and maybe special extra sessions for people. I'll say a little bit about this in a minute.
Mhm.
Like for people who don't have as strong a math background, for instance, I might host some special sessions, but that's basically 10, 20 classes in total of about 2 to 2.5 hours each class.
Okay. And how does this fit into the vision we talked about?
Yeah, so I mean, science obviously is a ubiquitous and critical feature of the modern world, but most people, I think, don't have a good sense of how we know the things that's how we know the things that we know in the scientific realm, or what the scientific method consists of, how scientists think and how they view the world. Um, so I think any educated person should know something about that. They should know something about, the origins of the basic, our basic understanding of the physical world, and have some sense of how that knowledge comes about. When people don't have that understanding, I think it's really, you see all around us, very anti-science kinds of perspectives. I mean, just
Hmm.
the fact that the phenomenon of creationism is as widespread as it is insane.
Hmm.
You know, after 400 years of modern science, and after Darwin, and after everything that we know and have learned, the fact that people can still cling to mythological views is just crazy. So, and I think it's partly because um, people don't have a good sense of where this knowledge comes from and how it's connected to reality. And even people who do study the physical sciences, the methods by which they study them also don't necessarily make it super clear how it's connected to reality, how the knowledge was developed, and to how to continue in the process of developing new knowledge. So um, I think it's a core. We talked about trying to provide a foundation for life by looking at sort of the core pillars of human knowledge. Science obviously is a major one, and that's why this is a part of it.
Okay.
I can also
And
say,
just,
this. Yeah, go ahead.
well, I was going to ask just to clarify. So this is a not an intro fit to physics course like you'd get in college, like an
Yeah, it's
intro
not
level
so.
course. Yeah.
Right. So if you go to college and you take an intro, like a 100 level 1 year physics course, they're going to cover all the major aspects of physics. They're going to talk about, the motion. They're going to talk about gravitation, kinematics. They're going to talk about wave theory, electricity and magnetism. They cover the whole. They want to give an introduction to the whole subject. So that is not what this is going to be. This is, as I said, it's very delimited. We're going to be focused just on the development of the laws of motion and gravitation. Um, but it's also, yeah. And it's going to take an approach that you wouldn't get in an intro physics course, because what we're going to be doing is tracing the historical development of the knowledge from the earliest, perceptual observations that people made um, up through the discoveries that Newton wrote down. So it's not an intro physics course. It's not, even though we're taking a historical approach, it's not a history of science course either. It's not gonna be. I'll be saying a lot about historical figures and their discoveries, but a history of science course, the focus there would really be on going through every step of the history, and really understanding what they were doing in their historical context and that sort of thing. So it's not intro physics, it's not history of science, and it's not philosophy of science. um, I'm not a philosopher, and I'm not really qualified, I think, to present, for instance, like present the theory of induction or anything like that. But the I think some philosophical issues will come out in the course.
Okay.
So it's looking, and we'll say a little bit more about what I mean by the foundations of physical science. But
Mhm.
that's basically what we're covering.
Yeah. So if I want to take your course, but I don't really have much of a math science background, am I going to struggle? Are we going to do calculus and uh, differential equations, or are we
No,
going
no,
to
no. Yeah,
keep it simple? Yeah.
yeah. So the aim is that I'm not going to assume any physics or any math background. Basically, I will be using math sort of at the level of high school algebra and trigonometry. Um, but I would say that I really want to stress that if you're somebody who always hated math, or you're scared of math, or you didn't, get math in high school, don't let that deter you from taking this course, because I first of all I plan to, early on in the course, I will plan to hold an extra session or two, maybe for people who need a review or an introduction to, basic algebra and trigonometry. The other thing is, like, if part of what you dislike about math is that, when you, let's say you studied trigonometry in high school, you know so what is trigonometry? Trigonometry is the study of how different parts of triangles relate to each other. Well, why the hell does anybody need to know how different parts of triangles relate to each other? I mean, the way it's presented is just presented as like, okay, there's triangles, they got angles, they got lengths of sides, how do those relate to each other? Let's study all this stuff. And for the most part, it's not well motivated at all, and it's easy for people to find it totally boring. Why do we even need to learn this? And partly it's just a failing of how it's done, how it's taught, how it's presented. What's interesting is, if you look at the history of trigonometry as an area of math, what's interesting is that, it was largely astronomers. Early ancient Greek astronomers are the people who basically invented trigonometry because they needed it in order to do the mathematical astronomy that they were doing. So some of the people who are the founders of trigonometry are Aristarchus, who's one of the astronomers that we're going to be talking about in the course, and Hipparchus was an ancient Greek astronomer, and they developed trigonometry because they needed it in order to, study the things that they were studying and looking at the properties of, the motions of the heavenly bodies. So uh, even if you hated trigonometry and didn't see what the point was, if you take my course, I will hopefully try to do it in a way that makes it super clear how valuable and how interesting and how important this subject is for you. So math phobes are welcome in the course. That was maybe longer than I wanted to go on, but I really want people to not be deterred by issues of math. If you think of yourself as a logical person, that's all you need for this.
Okay. What kind of work should a student expect to do? So we're not going to get into super complicated math, but the math we will have, will we have practice problems? Will we have to calculate the orbit of Mars? What are we going to do in class?
Well, I don't think the orbit of Mars is complicated. That took Kepler's genius to figure that out. But yeah, I'm still figuring out exactly what the homework will look like. Likely there will be some math problems, but not anything too complicated. There'll probably be some writing assignments. So that I'm still working on that. What kind of work there is. A lot of it will just be, you know, um, being attentive in the lectures and making sure you're grasping the material, because that's where a lot of the work is going to happen. There's not even going to be a ton of reading. I will be using two books that I'm going to be assigning as required text. I'm going to have a long reading list of sort of optional works. There's a ton of interesting book, obviously about the history of science and about these topics in particular. So there'll be, if you want to go down a rabbit hole of reading, dozens of books on all these subjects, I can provide references. But there are two books that I'll be using as required text. Maybe we could put those covers up. We're actually going to be using a book called The Logical Leap. So this was written by Dave Harriman, and it was written sort of in collaboration with Leonard Peikoff. And what the book presents is a theory of scientific induction that was developed by Dr. Peikoff, and and to a large extent, it's illustrated by and validated by, episodes from the history of science. So a lot of the material that we'll be covering in this course is covered in chapters 3 and 4 of this book. And so we're going to be using the book as a textbook. Again, not because we're going to be discussing the theory of induction explicitly. That's not going to be the focus of the course, but the physical science background that was part of the presentation of Dr. Peikoff's theory of induction is relevant to what we'll be talking about. That is what we'll be covering, and so we're going to use that as a textbook. The other text, but again, the sections of it are quite short, so it's not. This isn't going to be like tons and tons of reading. The other book we're going to be using, if we can get that up. So this is a book called "The Stars: A New Way to See Them." It's sort of an introduction to astronomy. We're not going to be going through it systematically because, again, like this isn't an astronomy course either, right? But some of the material that's in here will be is really useful for explaining what we see in the sky, and so parts of it are going to be relevant to understanding some of the material that we need to understand in the course. And if the name H.A. Rey looks familiar to you, yes, that is the guy who wrote the Curious George books. He was an amateur astronomer. He was really into it, and he wrote this. This is sort of a classic introduction to astronomy that he wrote, and part of what's awesome about this book is it's got tons of hand-drawn illustrations by H.A. Rey that are like you can see the Curious George style in them, but they're super useful in explaining different aspects of the solar system and so on. So we'll be using this one as a textbook as well.
Okay. So I want to get into more of the details of the course content. So you mentioned that we're looking at the progression from the ancient Babylonian astronomers up through Newton's discovery of the law of universal gravitation, and we're thinking of this as like the accumulation of evidence over centuries to the formation of a theory. What's the value in learning the ancient astronomy and the techniques of observational astronomy? I mean, if I want to find something in the night sky, isn't there an app for that now? Like, why do I need to learn the Babylonian techniques of locating the position of Mars?
Yeah. So I mean, that's a great place to start because that gets us right into what it means when we say that this course is sort of informed by objectivism's radical framework, right? So and what's the difference between this course and sort of a standard physics course that you might get? So if you ask the question, what are the foundations of knowledge? We're calling this the foundations of physical science. So when Tal gave this presentation at OCON and mentioned that one of the courses would be a course on the foundations of physical science, somebody came up to me afterwards and said, "Oh, you're doing the foundations of physical science, so you must be starting with quantum theory, right? You're going to talk about the basic building blocks of matter, and how we go from that, in this kind of reductionist sense, like up to chemistry and physics, all this stuff." So the point is that's exactly not the way to think about this. If you ask what are the foundations of knowledge, the foundation of all knowledge is sense perception. And so the question is, if you have any item of knowledge that you claim, anything you claim to know, how do you know it? The way you in order to understand how a person knows it, you have to be able to trace it back to perceptual observation ultimately. And so the reason for starting with ancient observational astronomy is that it's the observations of the things in the sky. That's what gives rise to all of this knowledge in the first place. That's what the knowledge is based on, is what you actually see when you look in the sky. I mean, just to concretize this a little bit, you ask any educated person today, and they'll say, well, they know, that the Earth is a planet, that it orbits the sun once a year, it rotates on its axis once a day. But if you ask them, how do we actually know that? Let's like if you didn't have space shuttles and space-based telescopes and all that sort of thing. Like, how would you actually show that that's true? You know, uh, so maybe we can show this image. Like, if you actually look up at the sky, this is what you see, right? Um, we all have this image of a bird's eye view of the solar system with the planets going around it and so on. And so oh yeah, we know that that's what happens. But if you actually go outside at night, like, this is what you actually see. So how do you get from this to the understanding that Newton developed of the solar system and the laws of motion, the laws of gravitation, the law of gravitation? Um, so that so how human knowledge builds up from perceptual observation to these very deep conceptual principles, that is what we're going to be that's what it means to understand the foundations of a subject, and that's what we're going to be covering. um, I mean, I have another, just to give another example of this. How do we even know that there is such a thing as a planet? Okay, like, you can go out and see them in the night sky, right? You can use one of those apps to say to like, I have a couple of these apps on my phone, and they're great because you can point it up there and it'll tell you, like, oh, that's Jupiter or that's Mars. But if you didn't have an app and you didn't have someone to tell you, hey, that's Mars, like, how would you even know that there is such a thing? And so, you know where does this concept even come from in the first place? So the way we actually know that there are these objects in the sky that look like stars, but they behave differently from stars. Uh, just to give a little context here. So if you go out and you look at the night sky, you see all these stars, and over millennia, people have named these stars. They've mapped their exact positions, and what you observe is that even as they rise in the east and set in the west, just like the sun does every day, they move through the sky overhead, they maintain their positions relative to each other. So there's this fixed map of stars, and we know this because we've formed constellations based on we're so familiar with their groupings that we can form these constellations. So we're showing an image here, of the Gemini, the twins, Orion, the Hunter, right? Um, so you so and these stars are fixed with respect to each other. They mean, from the perspective of somebody standing on the earth looking up at the night sky, these stars remain in their position even as the whole thing rotates around the sky from east to west every night, right? Now, but if you observe the sky over many nights, over weeks, over months, over years, what you discover is that there are a tiny number of objects. So there's thousands of stars in the sky, but just a few of them, some of the brightest ones, actually behave differently. So um, so you have all these stars that are fixed in place with respect to one another, but then what you see is that there are a few that aren't fixed in place. So let's go to the next image. Okay, so if you look at a different time of the month, you'll see that this red star that we're calling Mars, is in a different position in the constellation Taurus, the bull. So just let's go back and forth between them. So, at one time of the month, you'll see Mars in this location in the constellation Taurus. 20 days later or so, you'll see it in a different location. So in contrast to all these stars that are fixed in place, there are these other star-like things that seem to wander through the sky. And the Greek word for wandering star is planet. So this is like, historically, this is where the concept of planet even comes from in the first place. This is how we know that there is such a thing as a planet. And there were so there were seven wandering stars or wandering objects that were known to the ancients. There's five planets that are visible. Mercury, Venus, Mars, Jupiter, Saturn, and then the sun and the moon also wander through the stars. Um, so those seven objects, unlike all the rest of the stars in the sky that remain fixed in place with respect to each other, these other seven objects wander through the sky, and that's where we even have the concept of a planet in the first place. So that's just an example. How many people watching this podcast today knew that history and knew that like they all think they know what a planet is? Well, yeah, it's these things in our solar system. But how did that knowledge come about? What gave rise to the concept in the first place?
So
Um,
Keith,
if you,
who were the
yeah,
first people? Who were the first people to realize that there are wandering stars? Was it the Babylonians? Is this a pre-recorded history
I
discovery?
think it's definitely a pre-recorded history discovery, and the Babylonians kept very detailed records
Mhm.
of the motions of the sun, the moon, and the five visible planets that are visible to the naked eye. And they had, the Babylonians actually had very detailed mathematical theories for predicting, uh, for instance, the phases of the moon. Um, it was very important for them for the purposes of their calendar. So a lot of this stuff was motivated by just the cycle of the seasons.
Mm.
People needed, just imagine yourself back in prehistoric times. For one thing, like it's hard for us in the electric age to imagine, to project like what life is like in the pre-electric age. Before Thomas Edison, basically when the sun went down, you know it was dark. And
Mm.
so I think ancient people were much more knowledgeable, probably much more knowledgeable about what you see in the night sky than most people today. We don't you know
Well, you put up that image, and I thought to myself, I wished, I wish the sky above my home looked like that.
Well, that's, yeah, it's obviously a challenge to get a clear. I mean, so a lot of the most detailed observations and records were in Egypt and Babylon, ancient Mesopotamia. I think they probably benefited from clearer night skies than in some parts of the country here. I'm
Yeah.
in Southern California, so I'm lucky to have clear skies a lot. I mean, the other the other thing that we have is what astronomers call light pollution, but that's sort of a pet peeve of mine because it's basically the perspective that it has is, we have this incredible benefit of modern civilization and electric light that, we live in these modern cities, that are powered by energy. I mean, it's this is like we have a quality of life that's unprecedented in human history as a result of all of this technology, and 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 then they refer to it as light pollution.
Pollution.
Light
Mm.
is not a pollution. Light is a
Gift,
enormous benefit.
achievement.
So
Yeah.
yeah, exactly. So now I get the perspective though, because if you're trying to do astronomy, the fact that there's this huge background, let's call it background illumination, okay, not light pollution. There's a lot of background illumination that makes it harder to do observational astronomy, you know, near large cities. And that is a challenge, but I don't want to call it light pollution.
Fair enough.
Yeah. Um, so the point is, ancient people uh, knew a lot of these things. They knew a lot about the motions of the bodies in the sky. By the time you get to the birth of civilization and civilizations that were keeping written records, Egypt, the ancient Babylon, um, they were keeping detailed records of their observations. And when you start keeping records over, not just days and weeks and months, but even years and even centuries, comparing like this is one of the things we'll be talking about, is like some discoveries that people made in ancient Greece um, were a result of looking at the sky today versus even millennia ago based on these ancient records. And so you can integrate observations over long time periods like this and discover uh, uh, discover things that you can't just see if you just go out and look, on any given night. Um, so that's really important as well. Um, but what's interesting is, um, yeah, so the Babylonians had these detailed records, and I was saying they needed to be able to figure out what day the new moon would occur, because they had a lunar solar calendar. So they needed to know what the start of the new month was going to be. And so they developed these very sophisticated mathematical models, basically based on arithmetic progressions, that allowed them to figure that kind of thing out. Um, so based on keeping such careful records of their observations of these bodies.
Okay. So I did mention uh, there being an app for some of this. Are you going to use
Oh
the
yeah,
any apps in your course for
yeah.
getting astronomy?
So I mean, I mentioned that some of the things that we'll be talking about require, observing things in the sky over extended periods of time. Now, obviously, if you're sitting in a 2-hour class and I'm planning to teach it during the day, so we can't all go outside and be looking at things. I'm going to be using an app that'll allow us to visualize some of the motions of the heavenly bodies that occur over extended periods of time. So there's an app called Sky Safari that I'm going to use. And what I'll be doing is I'll be showing little video clips, images and video clips. Actually, those pictures of Mars that we just looked at, those were screenshots from the Sky Safari app. So there's all kinds of like really cool astronomy apps like this that are useful for not just for visualizing what you can see in the sky, and you can actually you can change the time increments. So instead of looking, just at a snapshot, you can say, let's advance time by an hour or by a day or by a month or something like that, and you can look at how things change over that time period, and that allows you to um, see what the motions of these bodies are over different time frames. Because
Hmm.
so some of the things that we're going to be talking about are things that you would only discover if you go out and you look, on one day, and then you compare your observation, like with the image of Mars there. In order to see that Mars is a wandering star, that it changes its position with respect to the fixed stars, you've got to go out and you've got to look at it on one night and then remember where it was and compare that observation to, an observation that you make 20 days later. Then
Hmm.
but again, like I was saying, if you imagine prehistoric people with no electric light, if you're some uh, if you're some kid who's assigned to watch the sheep, and you're out there every night anyway. uh, it's not surprising that ancient people would have made these observations, would have been able over centuries, millennia of human development, that the kinds of observations that we're talking about would have been apparent to them, because they would be, because they would be able to integrate these observations over long periods of time like that.
Mhm.
So it's not surprising that they would discover it, even if it does require this kind of integration of perceptual observations over that time frame. But for the purposes of the course, what will help us to integrate these perceptions over time is using an app where we can change the time increments. So I wanted to give an example of this just to show you the kind of thing that we're doing. I have a little video clip here. So this is, we're looking to the north, and you can see all the stars. So these are moving in 1 minute increments, but very quickly. And you can see, maybe we can run this clip again. So you can see the North Star. Um, so in the center there, you see there's a star that's not moving at all, and that's Polaris, the North Star. And all the other stars are sort of rising in the east and circling around and then setting in the west. But now if you just go out at night, you don't see them moving like this. You see them at one time, and then if you look 2 hours later, you'll see that they've rotated. That's what you actually see. But in order to understand the motions of the bodies, we want to be able to see how they move over extended periods of time. So this is sort of from dusk till dawn. You see how the app includes a daylight setting. So you're seeing it from sunset to sundown. You see, this is how the stars. You can actually see Cassiopeia, that sort of W-looking set of stars, kind of rotating around the North Star. Um, so we'll be using an app to help visualize. So that's good. We can stop showing the clip now. But we'll be using an app that I think it'll be uh, really helpful. I'll be able to show people what I'm talking about when I talk about the things that one sees in the night sky, um, using this app. It'll be uh, super helpful.
Great. So, is there anything else as far as course content that you wanted to highlight for us?
Yeah, I mean, I see we're already. I
We got about 10 minutes left. Yeah.
Yeah, one hazard here is I'm so excited about this stuff that I could geek on about this for hours. So
Well, you could just give us the course right now. It's
yeah, well, yeah, I mean, we could just start it. So just briefly, I can kind of briefly give an overview of the course outline. So as I said, we're gonna start with these observations, that were known to ancient civilizations. Um, but they didn't. So even though they had very detailed records, very detailed observations, they didn't really have any kind of causal understanding of what they were seeing. I mentioned the Babylonians kept these very detailed records about the phases of the moon. I don't think, I'm still trying to nail this down for sure, but I don't think they understood that the phases of the moon are caused by its position relative to the sun and the sunlight illuminating half the surface of the moon, and where it is from the point of view of the earth. Their perspective on what the moon and the sun were was mythological, right? That it's this godlike body that moves through the sky, and then when it sets in the east, it gets on a boat and rides through the underworld so that it can rise again in the east the next day. You know, um, the idea that it's a spherical body that's out there in space that's being illuminated by the sun, and we see the phases for that reason. I don't think they had that understanding. So the birth of science and the birth it really occurred in ancient Greece, and that's when the idea of trying to come up with consistent, logical, natural, as opposed to mystical, scientific understanding of things. That's when that began.
So
So
I
we're
wanted
going,
to ask you about
yeah,
since it's not a philosophy of science class, philosophical issues must come up in some places though. So, and this sounds like one of those places. Maybe the scientific revolution is another. What kind of things will we be talking about of a philosophical flavor?
yeah. So I think the distinction between the sort of philosophical framework that you get in ancient Greece versus pre-Greek civilizations is one difference that we'll be talking about, and that partly helps to explain why it is that the Greeks were the first to really make progress in this. Some of the philosophical premises that were underlying, the work done by people like Ptolemy, who had this sort of very complete um, model for for calculating planetary motions, but it's based on very unrealistic and unphysical assumptions. People have heard of like these epicycles and features like that. Um,
The
uh,
Ptolemaic model is with the Earth at the center.
yes, and yeah. Well, maybe I'm getting a little ahead of myself in terms of trying to make it clear what the problems are. But there are definitely philosophical problems that come up with Ptolemy's model, even with Copernicus and so on. So one thing I was going to suggest actually for people who want to, if people are interested in taking my course and they want to know what sort of background, what sort of preparation they might do, Leonard Peikoff's History of Philosophy course, which is available on our campus website, campus.aynrand.org, that gives really that what that tells you is um, what what was the birth of philosophy in ancient Greece, and what were some of the problems that they were considering, what were the issues that they were focused on. You get a lot about the pre-Socratics, about Plato, about Aristotle, and I'm not going to be covering a lot of that in my course, obviously, because it's not a history of philosophy course. But if you know, or if you remind yourself about that historical context, that'll be useful for this course. Not required, obviously, but it'll be useful. So we're going to be covering, as I said, we're going to be covering sort of ancient pre-Greek observations. We're going to be talking about the first physical theories of motion and first theories that try to explain the motions of the heavenly bodies in ancient Greece. So the models that were developed by Eudoxus and refined by Aristotle. We're going to be talking about spending a lot of time um, on the discoveries made by Hellenistic astronomers. So that's sort of the um, uh, what was it, sort of third century through the Roman period, roughly in the
Yeah,
Greek world. Discoveries made by Aristarchus, by Eratosthenes, by Hipparchus, and then culminating in sort of in the Ptolemaic model, um, which was kind of the standard model of the planetary motions for centuries until you get to Copernicus. So then we're going to talk about the Copernican revolution. And actually, that's so in terms of the course breakdown, the first quarter is, I think it's likely that we'll end with Copernicus. So we'll talk about the Copernican revolution and stop there. And then in the second quarter, we'll talk about what we refer to as the scientific revolution. So figures like Tycho Brahe, the great observational astronomer, Johannes Kepler, Galileo, and Newton. And that's so
great.
those figures and their work will be covering the second part.
Well, I'm really looking forward to that. And it sounds like even someone with a physics degree or an astronomy degree is going to learn a lot that they didn't get out of a college curriculum. So
I think
I'm
so. I mean, I
excited.
really view this course as being accessible to and interesting to basically anybody. You know, if you're even if you're somebody with a physics degree, you probably never learned this historical progression. And so I think you would find this interesting because it'll be new material. Most of what you'll be learning is new material, and the order of the discoveries and how they build on each other is something you wouldn't have gotten in a physics course. So I think you'd find that interesting. You know, if you're somebody who's studied astronomy, I don't know how much basic observational astronomy people get in it. I don't, I'm not that familiar with what's taught in astronomy courses, but usually they spend a little bit of time on observation, and then they go right to a lot
Hmm.
of theory and telescope observations and things like that. So I think even and the use of astronomy as the foundation for our understanding of motion and gravitation, that's not something that is tracing that historical development is not something you typically get in an astronomy class. So um, yeah, I think everybody should take this course.
Okay. Well, I think so too. I'll be in the audience for the whole thing. So I think that's all the time we have for today.
Yeah, I see that we have a
So
couple. I see we have a couple
do we want to do a
questions that I'd
few
like to.
questions? We can take a few
Well,
minutes.
so somebody's asking. I guess this is in reference to when we were talking about the course expansion. Someone asked, "No course on economics." Economics is definitely one of the subjects that we want to include. We're working on that. Psychology is another field that I think is essential. Um, even courses on different periods in history, I think taught from an objectivist framework would be valuable. So, as I said, this is just the beginning of the ARU course expansion, um, what we're going to be offering this year, but we definitely hope to get to some of these other ones. Um,
This question here, any future plans for course on gender, quantum physics, postmodernism, feminism? Well, the critical race theory class covers issues of gender, feminism, and postmodernism. Um, Quantum mechanics, I guess, is the odd man out in that list, but maybe a quantum
well,
mechanics class some years in the future, Keith?
I mean, we're gonna. So as I said, this course that I'm offering covers a very delimited aspect of the history of physical science. Um, I'm hoping, let me put it that way, that I could continue this and do a whole series of courses like this that would cover other topics, electricity and magnetism, the atomic theory, and I think it ultimately I would love to be able to get to modern physics. There's definitely some things that I would want to, I would love to do a course on special and general relativity, which is actually that's what my background is in my physics PhD. It was in
Mhm.
relativistic astrophysics. So, and I think I could do that also without having to make it too mathematical. And then in terms of quantum theory, quantum physics, um, there's definitely room for a course that goes through the major discoveries in the 19th century that gave rise to quantum physics. I don't, we couldn't do it in its full mathematical glory, but why the subject even exists in the first place, why it was necessary to develop quantum theory. Um, I would love to do a course on that too. So I can't make any promises because all this is very, like, right now we know what we're doing in this upcoming year, but I would love to do this eventually, and maybe if people write in and say they would love to have courses on this, we could justify it. So um, yeah, so I think we should wrap up.
Wrap up. Yep.
Um,
Uh, okay, so thank you for everyone who sent in a question, and those of you who made super chat donations on YouTube. We appreciate your support. So I think we have some resources to share that you might want to look at today. I think the history of philosophy course is the major one that Keith recommended, particularly the sections on ancient philosophy. Is that right, Keith? Um, and next week's show is going to be on not everyone who is mistaken is evil, but some are. You can join. Yeah, the title's funny. You can join uh, our senior fellow Ankar Gate and fellow Ben Bayer for a discussion of the issue of the evil or not evil of mistaken ideas. And that's on Wednesday at the usual times. Please send us your questions for future Q&A episodes. We do about once every 5 or 6 weeks a general open Q&A episode, but you can send us those questions at any time. We keep a queue, and you can send those to you can send those to newideal@aynrand.org. So even if we don't do an episode for 3 more weeks, if you send one today, it'll be in the queue. We'll look at it. If you enjoyed our podcast, please subscribe to our channel on YouTube and click the bell notifications to get notified when we go live or when we post new recordings. If you're watching the recording, please like, comment, and share the episode to help us attract new viewers. And please consider doing the same if you're watching on Facebook. If you have questions or comments on today's episode, or you have suggestions for future episodes, please email us again at newideal@aynrand.org. We read all the emails. We reply to many of them. So please send us your comments and suggestions there. So thanks again, Keith, for telling us about the ARU expansion, and especially thank you for telling us about your class, The Foundations of Physical Science.
Yeah, thanks.
See
This
you
was fun.
all. See you all in the future.